And one of the first things we learned from high-throughput glycomic studies is that glycans actually highly correlate with age. What we did a couple of years ago was to study over 5,000 people from 4 different cohorts, where we learned that younger people have more glycans which look like this, which act as an anti-inflammatory glycans and suppress inflammation, while older people would have glycans which look like this, and they actually promote inflammation. So glycans change with age, and actually, if we put only information about the glycans on IgG in our model, we can predict age of a person plus minus 9 years. Now, guessing a chronological age with an error of 9 years does not seem to be very accurate. But actually, if we would be predicting a chronological age too accurately, which is, for example, happening with the methylation clock, which guesses the age plus minus 1 year, then this does not give a lot of additional information. Actually, even Steve Horvath is now developing a new advanced methylation clocks because the original one does not give a lot of biological information. And also the other commercial methylation clocks are based on a different set of markers which correlates with the original methylation clock, but it's very hard to know what is the difference between the actually measured methylation age and the biological age, or what does it mean? For glycans, we know that the difference between the chronological age and the glycan age associates with a number of different biomarkers of unhealthy life. So if one is living a healthy life, his or her glycan age would be lower than a person who lives an unhealthy life. Also, we did a large study with over 27 populations all around the world and correlated glycan composition with the expected lifespan in the specific region. And we found a very high correlation between the glycan age and the expected lifespan, actually between the difference between the glycan age and the chronological age and the expected lifespan. So people living in the regions where expected lifespan would be shorter will have a higher relative glycan age compared to people living in a region where the expected lifespan would be longer. Also, by looking at thousands and thousands of patients with different diseases, we learned that effects of aging, which are these last 4 bars in all of the plots, are similar to the changes which we see in people with different diseases. So this is not an effect of a disease because we see it in many different diseases, but this is actually a reflection of biological process which we will believe to be a low-grade chronic inflammation, which is contributing to the development of these diseases. The way David Sinclair and I summarized this in a recent editorial in Aging, we said that the glycan age integrates genetic, epigenetic, and environmental information into a single biomarker, into a single value which can be reliably quantified. So actually, you have a single measure which includes genetic, epigenetic, and environmental aspects of aging. But even more importantly, these glycans are not only biomarkers, they're actually functional effectors which contribute to the function of the immune system and to the aging of the immune system.